Thanks everyone for joining us today. My name is Marianne of OWL Cyber Defense and the moderator for today's webinar. I'd like to introduce our speakers, Peter Fusaro and Paulo Silva. Peter is chairman of Global Change Associates, a New York-based energy and environmental strategy advisory. Peter is a New York Times best-selling author, thought leader, and leading international authority on sustainability, renewable energy, energy efficiency, and the transition to a low carbon economy. Paulo is the founder and CEO of Security Limits. He served IronGrid as a chief security architect with over 20 years of IT OT experience. He is an expert with operational security oversight of critical infrastructure assets and processes, as well as the creator of Ironclad. Before we begin, I'd like to invite our attendees to type their questions in the chat box provided, and we'll get to your questions after the presentation. And if we can't get to your questions after the presentation, you get an immediate response from one of us right after. Okay, so let's get started. Peter, the floor is yours.
Well, actually, I thought Paulo was going to do a little synopsis of part 1 and 2.
That's fine. That's fine. Absolutely.
So sorry. Yes.
So
Paulo.
I'm going to, yes. Thanks everybody for attending this webinar. I hope that you will find it very, very informational. This is part 3 of a 3-series webinar. In part 1, we discussed the strategies for securing the grid through segmentation and isolation. We basically spend a lot of time on the technical aspects of how existing utilities are operating today, their current environment, and also provided some insights as to what a 21st century architecture from a design and engineering perspective will look like in the near future. In part 2, we talked about strategies for complying with the presidential executive order, securing the United States bulk power system. Okay, with that being said, within the part 2, we talked about the NIST cybersecurity framework, which focused pretty much on identify, protect, detect, respond, and recover, very similar to ongoing efforts that we took to remediate against COVID-19, right? So there's a lot of similarities there. We presented the human immune system and how it reacts to things. When you start to put all of that into a cybersecurity, physical security context, we respond to incidents in a very similar fashion. There are a lot of similarities there. We also provided you an introduction to Ironclad, which is the world's first fully integrated and secured private cloud hyperconverged platform architecture. Okay, and also we talked about some of the convergence around regulations today, and some of the risks associated with the ongoing efforts to converge IT and OT environments. Without really having a global or enterprise design and engineering architecture that takes really security, that enables organizations to apply security controls from the ground up prior to going live. So as part of that recap, I'm going to now introduce you to part 3, strategies for securing the bulk power systems through perpetual CAPEX program, funding model with minimal OPEX expenses. I'm going to turn the floor to Peter Fusaro, and he'll provide you with some insights around the energy market and what that really means. Thank you. Peter?
Thank you, Pablo. The point is that the electric utility and gas utility industries have had tremendous changes in the last several decades due to deregulation, consolidation, and that's affected the CAPEX and OPEX management overview and budgets. So for example, today we have demand response, distributed energy, such as distributed solar energy, fleet retirement of existing power stations, much more renewables coming through RPS, Renewable Portfolio Standards. But the point being, there's much more complexity in the system than before. And that has obviously created more vulnerabilities to this system. So as the markets change, we've seen much more emphasis on regulatory changes, compliance, flexibility and need for resiliency within that system, and frankly, more focus on IT solutions. Legacy systems need to be upgraded and modified to meet more demands on a changing marketplace. And so forth. What we're looking at is a need for greater security in the cyber world due to threats beyond existing utility programs that we've seen for many decades. So there's a need for more robustness in the system. Paulo?
Yes, thank you, thank you. So one of the things that, as Marianne mentioned on the opening, I was the chief architect at Avangrid, which is an utility that's owned by Iberdrola SA over the past 2 years. And we deployed a technology called Ironclad there, which is pretty much a private cloud infrastructure. Okay, so a lot of utilities today in the marketplace, they have significant concerns moving their data from on-prem onto a public cloud solution. Okay, so there are a lot of companies out there such as AWS and Azure who are providing, a virtual private cloud. The concept alone is very contagious because it's hard for you to have a virtual private cloud because in the world of critical infrastructure protection, the physical interconnectivity of systems plays a major role, right, into how we secure the infrastructure. So, so one of the things that we've discovered over the years is that those virtual private cloud infrastructures within the public cloud itself were not really the best environment for utilities to move some of their applications and systems. And that's how we came up with the concept of Ironclad, which is the world's pretty much first private cloud infrastructure that's been designed and engineered, purpose-built to enable utilities to build their own on-prem private cloud infrastructure, very similar to how AWS actually runs theirs. The only difference is that we've taken the approach to integrate everything from an OSI layer model, layer 1 through layer 7, every component, everything from the DWDM and the fiber optic network that's built that eventually interconnects these data centers to the layer 7, which is providing the customers with an out-of-the-box experience in which all of the applications and tools, particularly physical and cybersecurity controls, have been implemented and integrated from the ground up. So when it's delivered, it comes with its own ITSM ServiceNow ticketing system. It has its own platform for, all the firewalls, all of the routing components, networking components have been fully integrated and secured, and the system is 100% NERC compliant. So in order for us to deploy Ironclad, right, and build this infrastructure, a lot of companies are working with Avangrid. We had to basically go in front of the Public Utility Commission and then talk to them about, what's the mission, right? What is it that we're trying to do? One of the use cases, in this case for this particular very large utility in the Northeast, was a use case associated with the amount of video traffic that was going through their legacy optical transport network. They had so much, after the Metcalf attack in California, they had so many video cameras deployed into the environment that eventually network bandwidth became an issue. And with network bandwidth becoming an issue, there came, network latency. So now they're trying to do load shed on substations. The commands are, sometimes packets are being dropped on the network. The commands are not being there. There are FERC regulations, right, that requires 4 milliseconds for command control. And all of that really, when you look at the architecture of utilities today through, decades of mergers and acquisitions, they ended up, consuming a lot of assets, IT, OT, infrastructure assets that were not really properly designed and they were not really properly vetted, right? So we continue to throw money into the legacy infrastructure, but a lot of companies didn't have a path to upgrade these systems into a 21st century architecture. So with that being said, we said, well, we went through in front of the Public Utility Commission. They went through this whole process of getting approved CAPEX approval, rate case approval for the program. And three things were defined, right, as part of a CAPEX cost strategy, that utilities can capitalize the convergence of some of their compliance program, right, especially if their compliance program is part of an overall architecture. It's part of a much bigger picture where you're taking all these tools, technological components, and you're putting everything and wrapping it around a single off-the-shelf solution that you can just buy. And that makes it a lot easier for regulators, especially if you're dealing with the Public Utility Commission, to understand what is it that you're acquiring as a new asset, the value that it brings to the organization, and the value that it adds over time to, to the public, to the people that are actually funding this through those rate cases, right? One of the things that also came out is that because we provide this private cloud solution as an out-of-the-box, off-the-shelf solution to the utility, this solution comes with an RFP package that's ready to go because we've already built it, we constructed, we documented. We have a manual actually that's transitioned when we go into operations as part of a training program that's delivered directly to the utility. And that RFP package actually reduces a tremendous amount of time to a procurement department within the utilities organization from having to really come up with all of the nuts and bolts of what really they need to purchase in order to build something, right? We already have that out of the box. So typically within a utility, especially if you're a global utility, a very large utility, right? Each department, they tend to pitch from a budget, just from a finance perspective, they have to build frameworks. Frameworks is, for example, if you have a security department within the organization and they would like to upgrade, they would like to perform physical and cybersecurity upgrades over a 3-year period, they would have to write up a framework that basically describes everything that they're planning to do and provide them with an estimate of cost of how long and how much it's going to cost to do it, right? Within that framework, eventually, if rate cases are approved, if they're part of a larger CAPEX bucket, right, of rate cases, some of the utilities have billions of dollars of capital expenditures already allocated over the next 3 years, okay, to spend money just to upgrade infrastructure all over the U.S., all across the U.S. If those frameworks are approved, eventually a budget is allocated for them. Once the budget is allocated, the project pretty much begins and they start, implementing. Well, the way the utilities keep these budgets honest is that they run typically budgets calculations on a quarterly basis, right? They monitor things on a monthly basis, but they pretty much balance their budgets on a quarterly basis, and they look for specific CAPEX programs that have, for example, that have not spent enough money during that quarter that are lagging behind. And if that money has not been spent based on what they projected, what the expenditure would be from a CAPEX perspective, that availability for that program now, that money becomes available from that program, which now gives the right to another program to come in and grab that availability for them if they are overspending in this case, right? And that's how they pretty much balance the ecosystem. So the framework describes what is to be done and how much it's going to cost. The budget money is allocated. It can be CAPEX or OPEX, 2 different buckets. And you ended up with availability keeps the framework honest, because if people are not spending money fast enough based on their schedule, they may take that money away, right? So as part of that RFP package that we put together for the utility, so the objective here is there are many different projects and programs within the organization, but the solution that we're offering is not a solution to immediately replace the legacy infrastructure, okay? Because we know that that's going to take about 10 years. The expectation here and the objectives of Ironclad and the value add is that we're encouraging the companies in working with the Public Utility Commission. We're working with Department of Energy. We're working with many different partners in the industry, including NIST, to help us take this design that has already been implemented in the Northeast and try to provide that design to utilities as a center of excellence, right? So if you don't have a roadmap of where you see your systems going over the next 10 years, and you do not have an enterprise centralized design and engineering infrastructure, perhaps this may be the solution for you, because it starts it's very cost effective when you deploy it initially, and it's designed to be cost effective in the initial deployment, because as you migrate applications onto it, the environment will grow, but because organizations already established the architecture, you just keep adding more CPU, memory, and storage to it. You don't need to pretty much retrofit to redesign anything. So there's tremendous savings there too. So when we go in front of the, when we develop the package and issue the license of Ironclad, we provide an RFP package to the procurement department. That RFP package eventually goes through a PUC approval process if budget's not available within the utility today, okay? But in many cases, utilities already have CAPEX budgets, and they may not require, going in front of the PUC at all, okay? And that's not a requirement. So typically a step one, as you're interacting with the PUC, for those that don't know, there's a notice that goes to the public, a notice to the public filing of the application or petitions. Step two would be the testimony evidence. They go through this whole process of, why should we do it and how that's going to benefit the people, like in that particular state where the utility operates. They also run through some kind of algorithm and calculation to figure out the return, what the rate case should be, right? How much the bill should increase and for how long. Step three, there's a briefing, and there's going back and forth between lawyers and whatnot that are representing these utilities during the rate case. And then step four, there's a final order and submission for vote to the commission, and that's where the commission reviews the package. And eventually, step five, go all once the package is reviewed by the commission, it is approved. The good news is that for the PUC, this process can actually be fast-tracked, because Ironclad is a solution that addresses the immediate needs of the executive order that was released on May 1st, right, in respect to protecting the bulk power system. And there's immediate benefits to national security right there, okay? So a lot of times what we see is a fast-track approach to the PUC approval, because everything is so well packaged, and because we have already deployed this infrastructure at a very large utility in the Northeast in the US, we've already set the precedence that it works and we know how to do it, right? I just put this here, fixing critical infrastructure in the US, for those that are listening, this is, the solution must fit into a financial model to appeal to investors, right? In order for you to be able to capitalize it. Utilities are run and managed by private and public traded companies. So we always have to keep that in mind, right? And as you can see on the Gilbert there, is basically saying we live in a world today that, it's all about, we need to focus on profitability, right? We want to upgrade critical infrastructure in the US. We wanted to address the issues around national security, right? To protect critical infrastructure, but we have to be smart about how we go about doing it, right? Because if we're not very smart and we're not able to demonstrate the return on investment, most likely we're not going to get the funds for it, because, like I said, these companies are publicly traded, or you have private equity companies that are controlling the decision-making process, right? Or majority investors in this case. So this is the typical current state of infrastructure of an utility today. This is what it looks like. It's very 5,000-foot level overview, but it basically describes that utilities have in a legacy OT and IT infrastructure. They have data centers deployed all around the country, depending on the size of the utility, right? If you're at Duke Energy, you have a significant amount of data centers, right? As a result of mergers and acquisitions over the years. And now a lot of the utilities are going through a data center consolidation. Now, it's funny because when I was working in banking, many years ago, banks went through a very similar process of data center consolidation. And I think the utilities industry is now finally going through that. And that's where the opportunity rises for the introduction of Ironclad in a very cost-effective manner, and I'll explain that how. So one of the current state for utilities is you have your satellite offices. Some utilities have substations. You ended up with your customer service centers. You have your corporate headquarters, right? Office buildings, and then you have to deal with your remote workers, and then you have your industrial control systems, ICS, OT WAN, right? Network. And now there's a major movement to converge IT and OT, because it's the natural convergence of where we're going, especially in the world of Internet of Things, right? Where we're putting sensors everywhere. It's all about reliability and introducing some level of resiliency within the infrastructure. Well, when you do that, what you're trying to do is basically take a decentralized network and a data center design that really didn't have much of an architecture put around it, right? Because this stuff is really outdated. It's old. It's been there for a long time, right? And we keep just throwing money at it and patching it. And it seems like we really don't have a way to leave their perpetual model where we're currently throwing all this money into a legacy infrastructure that over time it's just not sustainable. Based on what Peter mentioned, right? Where the markets are going and the complexities now that have been introduced into the energy sector in the US. So one of the things that that exists within the today's infrastructure is that we're also plagued with malicious code, right? So we already know that some of the fiber optic networks infrastructure in the US have been compromised, right? Utilities are responding to incidents pretty much on a daily basis, right? It's taking a tremendous amount of time from CIOs and CEOs, right? Instead of focusing on business transformation and growing the business, they're really in this sort of reactionary mode, constantly responding to threats, right? Getting phone calls from DHS, right? Getting information from the NSA, and all of that information that's being shared, through programs like Coyote and CRISP. There's a bunch of them. It's really becoming sort of extremely overwhelming for utilities, right? Trying to maintain that old legacy infrastructure. So what's the solution, right? How do we address that? Well, so Ironclad is the world's first only secure integrated private cloud platform, and it's a BlueSky approach. So once it's built and fully deployed, and it's built completely offsite, it consists of about 10 cabinets to 15 cabinets per site. And we basically deploy this system fully integrated, where we give the end user a zero client terminal that consists of a zero client terminal with 4 monitors on it, one for each environment within the design. And we integrate that system directly into your security operations center. So the reason why we do that first is that, number one, you're going to need to monitor that new private cloud environment. We interconnect that private cloud environment, which looks like something like this, where we introduce brand new fiber, or if the company has existing fiber available, we interconnect these 5 data centers, these 4 data centers in this case. There are 2 production environments, a QA environment, and a disaster recovery environment. So these cabinets are all built the same. They're built off-site, following a zero trust model, 15 isolation zones, and never connected to the internet. We have partners like Gigamon, Owl, Microsoft, Dell Technologies, all sending us, on physical portable media, military-grade encryption hard drives, all of their patches, all of the installation files, all offline. Right, so we really, when we build the system, it's 100% air gap. When we deliver the system, then there's a process in which we still apply some of those air gap controls, but there's a methodical process for actually integrating it into your existing data centers, where we interconnect all of these data centers with each other, but we do not bridge into your legacy old fiber optic network. There's a process for doing that, which also comes as part of the design, and I'll talk to that a little bit later. Within this design, some of the highlights is that we built this private cloud infrastructure, and the value-added proposition to utilities is that you have a lot of video traffic and access control traffic that's saturating your network. So when we put Ironclad and we deploy this private cloud infrastructure, which goes directly inside your existing data centers. So just imagine 10 additional cabinets, fully integrated, right? Layer 1 through layer 7, delivered into your existing data center. You provide us with A and B power and environmentally controlled room. And we integrate in all of the alarming systems and everything, right? So once that system is there, we interconnect them, and eventually we allow the migration of the sites. So first, we deploy HID or AMAG, which is fully configured within the system itself when we deliver it to you. If you're using AMAG for access control, or maybe using HID, we would integrate that into the Ironclad private cloud. And we would start then migrating the video feeds from particular sites, substations, service centers. There's a risk assessment process that we go through where we start bringing all those video feeds and communications now to be processed via this brand new private cloud 21st century architecture. So what that does immediately for utilities is that it frees up a lot of bandwidth on their network. So a lot of the FERC regulations, NERC stuff that, NERC requirements that are not being met now in respect to network latency and reliability, all of that would be immediately addressed in a very short period of time. And you start migrating all of these services and applications over time, okay? So basically the private cloud design has a proprietary transport network. It's IPv6 ready. We can do video surveillance standards, like this infrastructure when we deliver can process 720p and 20 frames per second for video in the infrastructure. It has built-in AI technology fully integrated and configured. It is NERC compliant when we give it to you, and all of the reports are actually automated, okay? When we give you Ironclad, it comes with own intranet portal, GRC tool, and then we have this whole automated process using IBM Rational Database, which it's really part of the overall compliance strategy within the architecture. Now, I don't want to bore you, but Ironclad, this is pretty much what it looks like. Okay, this is the high-level design. Everything is isolated. There's an outer enclave, an inner enclave, and that's how the private cloud is being architected. I'm just kind of showing it. We're not going to go through it because we don't want to get technical, but all of the components here, wherever these data centers, these cabinets are delivered to, that's how you're able to actually capitalize on that expenditure, right? Because now you don't need to worry about where every component is going. The whole capitalization of the program becomes, hey, it's a private cloud, right? So I have five subset of cabinets that will grow over time, but we're going to deploy them across various states, and that's how you're able to capitalize on that very effectively, okay? So within the Ironclad design, when we deploy or when we provide you with the private cloud infrastructure, it comes with a centralized architecture design engineering services. This is part of the architecture. So we basically take all of the burden of the maintenance from the utility. All of that is outsourced, where we are the ones that would monitor the market for new entrants in the marketplace, new technologies, right? We would test the technologies in our lab, and we would make, in this case, we make updates, engineering drawings, blueprints, whatever's necessary. We have what's called a life cycle management that's built in within that infrastructure, okay? And within that life cycle management, we basically take a lot of the burden from the utilities to figuring out, okay, what kind of tool do I get next? What's the next thing that's available? What's the next threat out there? And because, for utilities today, it's very difficult going through the whole process of product selection, testing, and eventually going through the procurement department, which can be a very time-consuming and lengthy process, that by the time you choose a particular security control or application or system to deploy in your environment, most likely that system is going to be obsolete by the time you're deployed, right? So within the centralized architecture, design, and engineering, the value added with the implementation of Ironclad as a holistic solution, 21st century architecture, right, going to the future, is that a lot of utilities over the years have gone through mergers and acquisitions, like I mentioned. And a lot of utilities today are operating where they have various design and engineering teams built or created or operating to support specifically programs and projects. One of the things that Ironclad helps utilities with is, with ROI, is by centralizing all of the design and engineering to make sure that in the future, all of the standard architecture of Ironclad and its lifecycle management model, that over time it does become the standard for the organization. Now, we do follow in a modular approach, which when we put the architecture together, which is what you see here, we are using two different types of firewalls, two different types of networking equipment. We're never really subscribed to one particular vendor, who in this case would end up owning most of the architecture. That was not the intent. We followed the Zachman pretty much our architecture model and framework. The system complies with NIST 853, ISO 27001. We put a lot of effort to create what's called a defense-in-depth architecture, so that utilities wouldn't be reliant on a particular vendor too much. And in case of cyber threats, if you ended up hacking the operating system of a particular vendor, next thing you know, 50% of the infrastructure would have been compromised or vulnerable. We didn't want that to happen. So we put a lot of defense-in-depth controls within the architecture itself. This is what CADES looks like when we deploy Ironclad, and this is all transparent to the utility. We manage it as a service, okay? Basically all of your design and engineering efforts for systems in the IT OT side would go through this oversight body that would consist of your full-time employees, in this case, the employees of the utilities themselves, senior leadership, sometimes management, that would participate with the engineering company, in this case, Security Limits, and we would be representing all of the different entities that you have there. And the design and engineering program, or from a governance perspective, we are one of the first engineering or technology companies that are providing this sort of CDM compliant, if you will, governance model for the architecture. Okay, and I don't know if you're familiar with CDM, but that was pretty much published by the Department of Homeland Security, and I would encourage you to to take a moment to read about it. It's very interesting. When we deploy Ironclad, we provide compliance through intelligence design, and we basically consolidate a lot of these initiatives. And remember, we're not really going to the organization and taking over your compliance organization. That's not the intent. We're providing very specific, templates, documentation, things that we know that works, because we've worked closely with, regulators in validating a lot of the content that makes up the overall Ironclad compliance program. So, when we're doing compliance through intelligence design, because you already have a design, we already know all the components that are in it, everything from, your network adapters to your physical links, to the networking devices, to the applications that are running within that infrastructure. So that's why we can give you a NERC-CIP compliant system out of the box, right? Because we pretty much assembled and integrated everything offsite. So by the time we deliver it to you, everything is already automated. So every time you need to migrate a new application into the Ironclad design, let's say you want to bring in MDMS, you want to bring in SCADA, maybe you even want to bring in your financial applications, right? Just to protect, because the way the architecture is set up, we have over 15 isolation zones. And maybe, the systems where they are in your legacy infrastructure today is not as, it doesn't have as much protection. So what we see happening now as part of the, as part of the deployment at this very large utility in the Northeast, we're starting to do a lot of the migration of applications and sites into the Ironclad design. Eventually, over time, the Ironclad design becomes your de facto standard design, where every site, every infrastructure across your, and this is pretty much within the context of head-end systems, right? Everything would become a very homogeneous environment where all the products would be, standardized from an architecture perspective, and you would end up with, different utilities running different types of solutions, which eventually becomes very complex and a nightmare to manage. You have ended up with the OT/IT lifecycle management options here. So today you have a decentralized design and engineering infrastructure, right? Design and engineering infrastructure, very decentralized. You have issues dealing with the legacy systems, outdated infrastructure, no cohesive design or architecture standards, right? Everything's being dealt with on a project by project basis, especially if those projects are CAPEX. lack of technology life cycle management, right? And then you ended up with regulations like NERC 13, which a lot of companies now are rushing to implement. Ironclad, when we deploy it, all of that is already there. So one of the benefits that we've seen in an Ironclad deployment is that because we've taken the time to automate a lot of the reporting and compliance, a lot of the companies actually deploy Ironclad, and now they're taking all of the code and all of the good stuff that we did there and pretty much expanding into the legacy environment, right? Because it's automated. I don't need to pay people to develop this stuff again. It's already built, and because we own it, we can replicate it across our environment. So there's a lot of opportunities there to save money. So what we provide is a commercial off-the-shelf solution. It's a private cloud solution that we just deploy into the utility. And the way it works is that we built that offsite, as you can see here in the dome on the right, and all the products are integrated, right? So that takes about 12 months. We put everything together. And then eventually we do a site survey. You tell us where you want the equipment delivered to, and you have your existing data centers, and we just deliver into your data center. When we deliver to your data center, you ended up with this little 10 cabinets of Ironclad there, and it's not connected to your existing network. It's completely isolated, right? As you start migrating applications and sites into the infrastructure, which are all built in parallel. So for example, if you wanna introduce SCADA over the next 2 years after we deployed, for example, after we deployed Ironclad into your data center, let's say that you would like to migrate SCADA. Maybe there's there are a lot of reasons. A lot of companies are going through SCADA migrations right now, even consolidation of systems or changing the platform altogether, okay, for various reasons. Well, because you have the private cloud hyper-converged infrastructure already in place and the security architecture all built in from the ground up, all you have to do is call Mitsubishi, you can call Siemens, you can call GE, and they come in and they install Alstom, Etera control platform, the SCADA systems, right into the critical zone in the design. We spawn the VMs, we give them the entire environment. They go there, they install, they run it, and once they're happy with the application running within that environment, now we start building fiber optic connectivity to substations or substations that are not that critical, in which can be used to calibrate the SCADA system. Okay, so all of that is happen. All of that happens in parallel to the day-to-day operations of the utility, and it's very non-impacting because now you have a brand new environment in which you can actually not only test things, but you can actually deploy live tools, let it run in parallel for a while, and eventually start just migrating more substations, right, by establishing brand new fiber optic connectivity directly to those sites. And that's how Ironclad eventually it starts to grow, because as you start introducing more applications, more services into the architecture, you need more CPU, memory, and storage, but you're not really spending a lot of time now redesigning things because you already have an enterprise architecture established for you. And that's one of the most important benefits of the design. Over time, Ironclad becomes your standard architecture, right, in your company. And with a lifecycle management where we provide updates on a regular basis, okay? Ironclad has a self-healing and resilient network infrastructure. So as part of the design, we have all of the low-level design documentation, blueprints, requirements, specifications for the network. We are product agnostic, so we offer, for example, as far as a DWDM is concerned, you can do a Sienna, or you can do a Cisco, or you can do a Nokia, right? So the architecture, we have the processes of how to integrate them and how to secure them. And there are some variances in respect to the capabilities of some of these products. And we also have all of that documented out of the box, which saves companies tremendous amount of time, right, from having to review these products. We have isolation segmentation. This is the architecture. One of the things that we mentioned is how you connect those substations to Ironclad, right? So we put a brand new fiber optic link there, and now Ironclad now is controlling that particular substation. And we start small, non-impacting substations, right? Things that really wouldn't impact the bulk electrical system, but enables us to calibrate SCADA. If you're doing MDMS, right? A lot of companies now are using Itron and using Itron in the cloud. Significant problems there, right? Just from an architecture and security, and also from a privacy and control of data, right? Because that's being provided in a public cloud. If the utility actually deploys Ironclad and has their own private cloud, well, your MDMS would actually run on-prem, right? And you would eventually connect. Now, in order for us to securely connect Ironclad or interconnect the networks, legacy, to this brand new 100G fiber optic network, we have what's called a demarcation or meet me point design. That meet me point design is a set of tools that's being specifically picked and integrated so that we can deploy it to every critical substation that's considered a BESS asset, right? In this case, any substation from a NERC perspective that, if rendered inoperable, could impact the bulk electrical system. We would deploy this meet me point cabinet to that substation so that we would provide not only, before we interconnect the networks, we would provide a full vulnerability assessment, scanning, physical security checks to make sure that there's no compromised systems within that environment. And this demarcation point would pretty much obtain packet captures and information about the site. So in case somebody, if you ended up with an insider threat scenario where somebody breaches physical security of the substation itself and attempts to introduce malicious code using a portable media drive or USB dongle, we would be able to actually not only detect, right, at the speed of light and report it to the SOC, but we would be able to proactively mitigate the propagation of that malicious code by shutting down communications to the substation. And there's a very technical aspect of the way we're doing that, because we have different lambdas within the fiber optic network as part of the architecture for SCADA commands, for AMI traffic, security traffic management ports, et cetera, et cetera. So that's a demarc isolation, that segmentation there. So that gets deployed to every site. So we're not only protecting, as part of a 21st century architecture, we're not just protecting the head-end systems. We're actually taking the protection controls out to the site and protect each critical site, right? To prevent the threat scenario where malicious code would be introduced into a substation and then hopped using the fiber optic network and infecting another substation without ever hitting the head-end systems or your SOC. Okay, these are simple of all the products that have been integrated within the architecture, and that's all I have. Back to you, Marianne.
Hi, thanks, Paulo. I appreciate your presentation. I hope everyone enjoyed it. Thank you very much to all the speakers. Paulo, if you have any questions or can share any questions that might the attendees have.
Yeah. Yeah, one of the questions here is, how do you ensure compliance of the architecture prior to delivery? And this is it's a very good question, but it's a very complex question. We have what's called a compliance governance program within the design that we have compliance managers and personnel working day to day alongside the engineers and the systems engineers and administrators as they're building the system. And we have a fully documented run book in respect to how we not only evaluate the regulatory compliance requirements that have to be applied to the environment, but also how we track them. We also have a quality control process that enables individuals to go in and actually validate for each requirement against a particular control objective, whether or not the evidence that's being gathered fulfills those requirements. And all of that is pretty much documented in a run book that's turned over to the client. And we also have independent assessors that come on site. So prior to delivering the system to the utility, we actually engage with NERC where they send the auditors on site for them to do an inspection before actually the system is delivered into the customer's facilities. Okay.
Great, super. Thank you very much for that question. We are out of time. I want to thank our speakers and attendees. I hope you enjoyed the webinar today. And any other questions that we have, you'll get a direct response right after this presentation. So thank you so much, everyone. Have a great day.
Thank you. Have a good day. Bye.
Bye.